So I understand that this lecture cut out before the end. I don't know how I screwed that up, but I guess I did. So I think we were right here where we were starting to talk about, we've done an example of synthetic division. So the example that we had looked at was 3x cubed plus 5x squared minus 8 divided by x plus 5. So the first thing we did was we set the divisor equal to 0 to figure out the number that goes outside of our synthetic division bar. And drew our synthetic division bar and use the coefficients of our dividend as the numbers here. So remember that there's no x term, so I had to include a 0 there. And then you bring the first number down, and we did negative 5 times 3 to give us negative 15. We add down, and we just kind of continue that until the end. So these four numbers at the bottom tell us two things. So I can think of it as a substitution, where if I'm plugging negative 5 into this polynomial, that gives me negative 258. The second thing is, it gives me the answer to the division problem, which is for us going to be the more interesting part. It tells me that 3x cubed plus 5x squared minus 8 divided by x plus 5 is equal to, again, starting from the far right, we have the remainder. So I have negative 258 over the divisor, which was x plus 5. And then we have plus 50, that's the constant, minus 10x, that's the coefficient on our x's, and then plus 3x squared. That's our coefficient on our x squareds. And we just keep going up 1 degree as we move to the left. Out here is nothing but 0, so we don't need to write any of those. But you start with the remainder at the far right, and then you have your degree 0 term or your constant term, your degree 1 term, your degree 2 term, degree 3, degree 4, degree 5, etc. So that gives you the solution to our division problem. This part we call the quotient, and this part we call the remainder. So this stuff is the quotient, and this is the remainder. Okay, so there's a special definition here. You remember when we looked at the division just with regular old whole numbers. Say we have 18 divided by 6. That gives us 3, right? That because I know that if I do 18 divided by 6, I get 3 with remainder 0. What that tells me is that 6 is a factor of 18. So we're going to use that interpretation now with polynomial divisions. So the key here is that we're getting a remainder 0. So let's consider this problem, x squared plus 5x plus 6 divided by x plus 2. So if I do my synthetic division, I put my negative 2 out here, and then I have a 1, 5, and 6 across the top. I do my synthetic division, and I get remainder 0. And my quotient is x plus 3. So I have that x squared plus 5x plus 6 divided by x plus 2 is equal to x plus 3. This also tells me something as well. So it says that the fraction x squared plus 5x plus 6 over x plus 2 is equal to x plus 3. Or if we multiply both sides by x plus 2, we get that x squared plus 5x plus 6 equals x plus 3 times x plus 2. So what this synthetic division process gives us is a way to factor. Now the key to being able to factor is that we have to have a remainder 0. If we do get a remainder 0, though, with a division, we're going to have that our dividend is equal to our divisor times the quotient. Only if you're getting a remainder 0, though. And this will become the building block of the next section. So an example from the homework on number 24, we're asked to factor this polynomial given that x plus 1 is one of its factors. So, given that I know that, I can do my synthetic division, and I should be getting a remainder 0. So again, I'm going to set this equal to 0 to get the negative 1, and then my 2, 7, 4, and negative 1 are my numbers across the top. When I do my synthetic division, I get 2, 5, negative 1, and then remainder 0. So that tells me x plus 1 is a factor, and specifically that my dividend, 2x cubed plus 7x squared plus 4x minus 1, is equal to my divisor times my quotient. Okay, and that should be your missing parts of that one.